Okay, your first question, f of x equals x divided by x plus 9, and you want to find the inverse of f of x. So the f of x is actually y, so y equals x over x plus 9. So all you're being asked to do is solve for x. So I need to get x on the left side of the equation and everything else on the right side of the equation. So I need to get rid of this bottom part. So I multiply both sides by x plus 9. If you do it to one side of the equation, you have to do it to the other side of the equation. So multiply both sides of the equation times x plus 9. Those divide out. So now I have x plus 9 times y equals x. So that's the same thing as saying, now just distribute it. So x times y plus 9 times y equals x. Now remember, I want to get x by itself, so I move this x over. I subtract. Let me write this better. So x times y plus 9 times y equals x. I'm trying to get x by itself, so I want to say x equals something. So I can move the 9y, I want to take that 9y, move it over there. So I have x plus x times y equals x minus 9y. And then I want to move this x over to this side. So x times y minus x equals minus 9y. So I just took that x and moved it over here by subtracting x from both sides. Now this is saying x times y minus 1 equals minus 9y. This means that x equals minus 9y over y minus 1. So those are the steps. Let's go on to the next question, which was, pull that up real quick, f of x equals x plus 2 squared. Find the inverse of f restricted to that domain. So I'll find the inverse of x. So y equals x plus 2 squared. I want to solve for x, so I'll take the square root of both sides. Square root of y equals x plus 2. Right, because if I take the square root of this side, it gets rid of that squared. And then subtract the 2. Square root of y minus 2 equals x. So x equals the square root of y minus 2. Now the other question was, find the entire domain on which the function f is one-to-one and non-decreasing. So when you see something that's squared, it's going to be shaped something like that, some kind of U shape to it. So where's it non-decreasing? So you kind of have to just work through this, but I know that, well, let me do it kind of maybe the long way here. So if I put in x and find y, so I have minus 3 for x, f of minus 3 equals minus 3 plus 2 squared. That's the same thing as 1. It's right about there. So put in minus 2 for x. F of minus 2 equals minus 2 plus 2 squared. That's 0. So this is 0. Put in minus 1 for x. F of minus 1 is equal to minus 1 plus 2 squared. That's equal to 1. And then 0. F of 0 equals 0 plus 2 squared. That's equal to 4. So if you go to the negatives, well, let me make it a little more clear. Minus 3 I'm at 1, minus 2, I'm at 0, minus 1, I'm at 1, and that's where I start to go up. So the important thing is, at this point right here, this is where I start to go up. So the y's start to get bigger. If I can draw that a little bit better, remember I'm not great at drawing, but if I can draw it a little bit better, I think you might see it a little bit better. Try to change color. It looks something like that, where this would be minus 3, so f of minus 3 is equal to minus 3 plus 2 squared, which is 1. It would be right there. F of minus 2 would be right here in 0. F of minus 1, it starts to go up right there. So the range, the answer is, it's from minus 2 to infinity, because it goes up all the way to infinity like that. I hope that's a good enough explanation for that one. And the next question is find the inverse. I've already done that one. So we have f of x equals 4x over x plus 1. And find the inverse. So y equals 4x over x plus 1. Solving for x, multiply both sides, so x plus 1 times y equals 4x over x plus 1 times x plus 1. Again, I multiply by x plus 1 on one side of the equation, I have to do that on the other. So this is x plus 1 times y is equal to 4x, right? Because those disappear. So xy plus y equals 4x. And I want to get the x's by themselves, so x times y minus 4x equals minus y. So I move the y over here, the 4x over there. X times y minus 4 equals negative y, which means x equals minus y over y minus 4. So it's just working through the algebra. Of course, if you don't follow any of that, just let me know. The next one, we have 5 minus 8i over 4i, and I will write that in the form a plus bi. Well, remember, I is equal to the square root of negative 1. Kind of the trick here is you want to multiply both sides. I mean, multiply this by I over I, not both sides. Multiply this by I over I. I divided by I is 1, so if I multiply an equation by 1, I've changed nothing. So I can do that. So if I multiply both sides by I over I, 5 times I is 5i, minus 8 times I squared, right? 8i times I is I squared, over 4i squared, because I times I. I squared is equal to negative 1. So what I have here is 5i minus 8 times negative 1 over 4 times negative 1, which is equal to 5i minus negative 8 is plus 8 over 4 times negative 1 is minus 4. That's equal to 5 over negative minus 5 over 4i. 8 divided by 4 is 2, and it's negative 2. I want to write it like this: negative 2 plus, not plus, minus 1.25i, because 5 over 4 is 1.25. And the last one, whoops, The last one is square root of 36 minus square root of negative 4 plus the square root of negative 25. And on your picture it said give, and I couldn't see what else it wanted to do, so I'm going to take a guess at what they want you to do with this. I think they want you to write it A plus BI form. Like I said, I can't see the whole thing from the picture you gave me. So square root of 36 is 6 minus, let's write it this way, minus 4 would be 4 times negative 1 plus square root of 25 times negative 1. So this would be 6 minus square root of 4 is 2, square root of negative 1 is I, plus square root of 25 is 5, square root of negative 1 is I. So this would then be 6 minus, or plus, minus 2 plus 5 is plus 3I. So hopefully that will help you out. Any questions, just let me know.